Voilà, soyez le bienvenu. This is Engineer Kanene. In this particular video, we review one of Zambia's marvel. It's a building, a frame structure by the name of LUSAKA Society Business Park. It's our interest that anything that has to do with construction, anything that has to do with structures, as engineers, we develop interest in those particular subjects. So here's an overview about Lusaka Society Business Park. This structure was officially opened in the year 2018 by a hotel group known as Hilton Hotel Group. This project costed about 100 million US dollars. It is no simple project. It was a mega project for the country of Zambia. Of course, there was some partnership between the Hilton Group and NAPSA, together with Zambia National Building Society. So now, when the building was opened, when this structure was opened in the year 2018, later by 2019, October 2019, the structure started experiencing or undergoing what we refer to as structural failures. Later, by the year 2023, somewhere 2022, 2023, it led to a complete closing of this superstructure or this structure. So now, let us first understand the components before we dive into what happened to the structure, what type of failures did it experience, because that is our main interest as engineers. Voila. So now, Society Business Park has got, let's say, 4 major components. There's the first component, which consists of a hotel. It has a hotel which is about 20 floors with about 148 rooms. Okay, very nice view, very nice rooms. Okay, then at the base there, it has a component of a mall. There's a shopping mall down there. Okay, besides the mall, there are offices. There's an office block, and attached to the office block, you have a multi-level parking space. It has about 800 plus parking spaces for vehicles. So it's quite some mega structure for Zambia. Now, what led to the closure of this particular project is that you discover that with time, the project started undergoing what are known as structural failures. By structural failures, we refer to structural members. Remember, from the inception of this video, I told you that this structure is a frame structure consisting of beams, columns, and slabs. There's that load transmission of the distribution of load until the load is transferred to the ground, the way the load is distributed to the ground through these structural members. And so these structural members started experiencing some failures. This is just a picture of one of the columns somewhere in the car park. So you can see that this column has failed. So what led to these columns, structural members such as the slabs and such as the columns and the beams to fail? What led to that? What type of failures do we have in the field of engineering? Okay, so before I present you the 3 types of failures that I'll give to you, I want you to understand one thing, is that this structure was deemed for the main hotel. It was deemed that it is still structurally sound and could be reopened. Okay, same applies with the mall. The mall is still fit, structurally sound. But the issue is that this structure works together. Okay, there's the load transmission is attached together. The parts that are affected is the office block and the multi-level parking space. So because it's linked together, the nodes are linked together. Remember, they are linked together. That is the reason why the whole entire building is closed, because it cannot work independently. When one goes down, the other. Why? Because the nodes are linked together. Okay, so I believe during the construction of this project, a proper research was done for the location of this particular project. Okay, bearing in mind that it is near very busy places where there are a lot of vehicles, a lot of vibration from the ground coming in. So all that, I'm sure, was very important to put into consideration. Voila. So now let's go. What type of structural failures do we have in the field of engineering, the field of structural engineering? Okay, voila. Here we go. So basically, I present you three types of structural failure. The first one is what is known as buckling. This happens, of course, these structure failures we're talking about in columns. There's what is known as buckling. Buckling deals with the slenderness of a column. When we talk about slenderness, we're talking about the effective height of the column. When the engineer does not properly design the column with relation to its axial load, relation to its depth, and relation to its height, the column experiences what is known as buckling. Okay? The column experiences what is known as buckling, where it wobbles and it bends in the lateral direction as indicated by the arrow there. It bends in this particular direction. And an example of buckling is what you're seeing in the picture here below. This is a column that has buckled. Okay, why? Because it was too high. Okay, it was too high, and its depth, column depth, was not designed, okay, as per axial load that is acting on the column. So this type of failure is what is known as buckling. Okay, so later I'll come to how we remedy these types of failures. The second type of failure we have in structures, especially in frame structures, is what is known as, the second one is a compression failure. The compression failure usually occurs in aspect when the axial load that is of which the column is subjected to, when the load is actually greater than the cross-sectional area of the column itself, it leads to the column experiencing what is known as compression failure. And this compression failure mostly occurs in short columns. Like, for example, what you're seeing here is a compression failure. Okay, when the load is too greater than what this column can actually bear, it does what? It compresses the column to an extent where it bulges. Okay, it bulges. Okay, you can see the reinforcement coming out in that particular direction simply means the load is doing what? Is greater than the cross-sectional area. To some extent, the concrete itself, remember this is reinforced cement concrete, the column. The concrete itself has to some degree able to bear the compression load, the axial load. But together with the reinforcement in the column, to some extent they're able to bear the load. But when the force applied is greater than the reinforcement and greater than what the concrete itself can bear, it leads to this type of failure. The third type of failure is what is known as shear failure. Shear failure usually occurs in situations where the column is subjected to lateral loads. We're talking about wind loads, we're talking about earth movements, earthquake, seismic movement, okay? And also, when your column has not been properly placed, the ties in the column, this deals with reinforcement, have not been properly placed, it leads to what is known as shear failure. So this is as a result of lateral movements, horizontal movements, which leads to shear failure. Looking at this this column that has failed for LUSAKA Society Business Park, you're even able to tell that look at the reinforcement bulging. This is as a result of compression failure. It's either this particular column was not placed at this particular location, particular position where it's supposed to be, okay, or it was not properly designed for the particular load. The size of the column was less than the weight or the load that is acting on the column itself. So these are the three types of structural failure that I present you. But deeper as you go in studies, you discover that we also have what is known as a combined stress failure. A combined stress failure, a buckling effect, like I have told you, a shear failure. There's also some failure due to lack of confined reinforcement. So when these reinforcements are not properly confined in the concrete, it leads to failure. Sometimes torsion effect, rotation. A building could rotate due to lateral movements, which can lead to torsion failure. Sometimes it's due to construction defects, okay, failing to comply with the standards, okay. Sometimes the failure can be due to errors in the construction itself, construction of material, the type of material that we are using. All these can lead to structural failures. But what we are looking at from this particular picture we have of Lusaka Society Business Park, that this column is doing what is failing. So allow me to dive into what is known as retrofitting. So retrofitting now is going to give us the solution before we arrive to this kind of failures. Let's look at retrofitting in structural engineering or in civil engineering at large.